Good morning, dear students. Welcome back to physics class. Today, I am going to discuss on two topics which are A. Bulk modulus and B. Its related numerical. From last class session, you understood when a body is under a fluid, it experiences a hydraulic stress. It is the ratio of restoring force developed in the submerged body per its unit area of cross section when force is applied by the fluid on the body. It is pointed that this hydraulic stress is equal in magnitude to the hydraulic pressure or the fluid pressure. Then, what is the strain produced due to the hydraulic stress called? It is volume strain or hydraulic strain. It is the ratio of decrease in the volume of the submerged body per its unit volume. Now, you are going to study about what is bulk modulus. It is the ratio of hydraulic stress to the corresponding hydraulic strain or volume strain. It is represented by the symbol capital letter B. Its mathematical expression is B is equal to minus P divided by delta V by V, where P be the hydraulic stress and delta V by V be the hydraulic strain or volume strain. The negative sign indicates that the increase in pressure results in decrease in volume. As P is positive, delta V should be negative. Consider a system which is in equilibrium or in balanced condition. Then, what should be the value of the bulk modulus be? It would be always positive. SI unit of bulk modulus is Newton per meter square or Pascal. 1 Newton per meter square is equal to 1 Pascal. This slide gives the bulk modulus of solids, liquids and gaseous substances. In this table, the magnitudes of the bulk modulus of the materials are expressed in the units Newton per meter square or gigapascals. You should note that 1 gigapascal is equal to 10 the power of 9 Newton per meter square. For example, the bulk modulus of aluminium is 72 into 10 the power of 9 Newton per meter square or 72 gigapascal. From this table, you can compare the bulk modulus of solid, liquid and gaseous substances each other, and it is seen that bulk modulus of solids is greater than the bulk modulus of liquid substances, which is greater than the bulk modulus of gaseous substances. Then, what should be the compressibility of a substance? Compressibility is the measure of compression of a substance. It is just a reciprocal of bulk modulus of a substance. How can it define? It can be defined as the fractional change in volume per unit increase in pressure. Bulk modulus is denoted by small letter k. How can it express mathematically? Its mathematical form is k is equal to 1 by b, which is equal to minus of 1 by delta p into delta v by v, since b is equal to minus delta p divided by delta v by v. You should note that as the bulk modulus of solid substances is greater than the bulk modulus of liquid substances, which is greater than the bulk modulus of gaseous substances, then the compressibility of solid substances is lesser than the compressibility of liquid substances, which is lesser than the compressibility of gaseous substances. What is the reason of lowest compressibility of solid substances? It is because of their compactness. Their compactness is due to the tight coupling between the neighboring atoms in it, or closed packing structure of their atoms. Thus, they have negligible interatomic distances which give rise to their compactness. It is the reason of their lowest compressibility or the highest bulk modulus. Regarding to the gaseous substances, they are most compressible because molecules in gaseous substances are very poorly coupled to their neighboring molecules, or they are very loose packed. They are free to move anywhere. So, the compressibility of gaseous substances is higher than both solid and liquid substances. Compressibility of gaseous substances is about 1,000,000 times more than the compressibility of solid substances. But in case of liquids, their molecules are also coupled to their neighboring molecules, but not as strong as in solid substances. So, the compressibility of liquids greater than solids but lower than gaseous substances. Question number 1. The bulk modulus for water is 2.1 gigapascal. Calculate the contraction in volume of 200 milliliter of water is subjected to a pressure of 2 million pascal. Given B is equal to 2 gigapascal is equal to 2.1 into 10 the power of 9 pascals. Given that volume of water V is equal to 200 milliliter, converting into meter cube, which is equal to 200 into 10 the power of minus 6 meter cube, since 1 milliliter is equal to 10 the power of minus 6 meter cube. And the pressure P is equal to 2 million pascals, since 1 million pascal is equal to 10 the power of 6 pascals, so it is equal to 2 into 10 the power of 6 pascals. We know that the bulk modulus B is equal to minus P divided by delta V by V is equal to minus PV by delta V. Then, what should be the contraction in volume? Let it be delta V. Delta V is equal to PV by B, since B is equal to minus PV by delta V. By substituting the values of P, V and B, we will get delta V is equal to 1.9 into 10 the power of minus 7 meter cube. By converting it into milliliter, it is equal to 0.19 milliliter, since 1 meter cube is equal to 10 the power of 6 milliliter. Second question is, compute the bulk modulus of water from the following data. Initial volume is equal to 100 liter. Pressure increase is equal to 100 atmosphere, since 1 atmospheric pressure is equal to 1.013 into 10 the power of 5 pascals. Final volume is equal to 100.5 liter. Compare the bulk modulus of water with that of air at constant temperature. Explain in simple terms why the ratio is so large. What is its solution? Here, given that initial volume V1 is equal to 100.0 liter. Converting into meter cube, it is equal to 100 into 10 the power of minus 3 meter cube. Final volume V2 is equal to 100.5 liter is equal to 100.5 into 10 the power of minus 3 meter cube. Then increase in volume delta V is equal to final volume minus initial volume is equal to 100.5 into 10 the power of minus 3 minus 100 into 10 the power of minus 3 is equal to 0.5 into 10 the power of minus 3 meter cube. Then what should be increasing pressure? It is delta P is equal to 100 atmosphere. Converting into Pascal, it should be multiplied by 1.013 into 10 the power of 5 pascals. It is 100 into 1.013 into 10 the power of 5 pascals. We know that bulk modulus B is equal to minus delta P by delta V by V. In this case, it is equal to delta P by delta V by V1 is equal to delta P into V1 by delta V. By substituting the values of delta P, V1 and delta V, we get the bulk modulus B is equal to 2.026 into 10 the power of 6 pascals. What is the bulk modulus of air? Since 1 atmospheric pressure or the pressure of atmospheric air is equal to 1.0 into 10 the power of 5 pascals, then the bulk modulus of the air is also the same value. It is equal to 1.0 into 10 the power of 5 pascal. What should be the ratio of bulk modulus of water to the bulk modulus of air? This ratio is 2.026 into 10 the power of 4. That is, bulk modulus of water is 2.026 into 10 the power of 4 times more than air. This ratio is very high because air is more compressible than water. Third question is, what is the density of water at a depth where pressure is 80 atmosphere, given that its density at the surface is 1.03 into 10 the power of 3 kilogram meter raised to minus 3. Given compressibility of water is equal to 1 by B is equal to 45.8 into 10 the power of minus 11 pascals raised to minus 1. Let the given depth be h, given that pressure at a given depth P is equal to 80 atmosphere. Converting into Pascal, we have to multiply it by 1.01 into 10 the power of 5. Density of water at the surface ρ1 is equal to 1.03 into 10 the power of 3 kilogram per meter cube. Let ρ2 be the density of water at the depth h. Let V1 be the volume of water or mass m at the surface. Let V2 be the volume of water or mass m at the depth h. Then, what should be the change in volume? Let it be delta V is equal to V1 minus V2, which is equal to m divided by ρ1 minus m divided by ρ2, since density ρ is equal to mass per unit volume m by V. Then V is equal to m by ρ. So delta V is equal to m into 1 divided by ρ1 minus 1 divided by ρ2. Therefore, volume strain or volumetric strain is equal to delta V by V1 is equal to m into 1 divided by rho 1 minus 1 divided by rho 2 whole divided by m by rho 1. It is equal to 1 minus rho 1 by rho 2, which is the expression 1. We have the expression 1, which is delta V by V1 is equal to 1 minus rho 1 by rho 2. Bulk modulus B is equal to P V1 by delta V. So, delta V by V1 is equal to P by B, which is the expression 2. We know that compressibility of water is equal to 45.8 into 10 the power of minus 11 Pascal raised to minus 1, which was already given. So, 1 by B is equal to 45.8 into 10 the power of minus 11 Pascal raised to minus 1, which is the expression 2a, since compressibility is the reciprocal of bulk modulus. By using the expressions 2 and 2a, we get delta V by V1 is equal to 3.71 into 10 the power of minus 3, which is the expression 3. By using the equations 1 and 3, we get 1 minus rho 1 by rho 2 is equal to 3.71 into 10 the power of minus 3. So, rho 1 by rho 2 is equal to 1 minus 3.71 into 10 the power of minus 3. Then, what is the value of rho 2? Rho 2 is equal to rho 1 by 1 minus 3.71 into 10 the power of minus 3. By substituting the value of rho 1, it is equal to 1.034 into 10 the power of 3 kilogram per meter cube. That is, density of water at given depth H is equal to 1.034 into 10 the power of 3 kilogram per meter cube. Fourth question is, determine the volume contraction of a solid copper cube 10 cm on an edge when subjected to a hydraulic pressure of 7.0 into 10 the power of 6 pascals. Given bulk modulus of copper is equal to 140 gigapascals. The solution is, given that length of each side of the solid cube of copper L is equal to 10 cm, converting into meter is equal to 0.1 meter. Hydraulic pressure P is equal to 7.0 into 10 the power of 6 pascals, converting into Newton per meter square. It is the same value. And bulk modulus K is equal to 140 gigapascals. Converting into Pascal, we have to multiply it by 10 the power of 9. We have to find volume contraction delta V. Volume of the solid cube V is equal to L cube is equal to 0.1 meter all cube. We know that bulk modulus B is equal to PV by delta V. Then delta V is equal to PV by B. By substituting the values of P, V and B, we get delta V is equal to 5 into 10 the power of minus 8 meter cube. It is the volume contraction. And fifth question is, the average depth of Indian Ocean is about 3000 meter. Calculate the fractional compression delta V by V of water at the bottom of the ocean, given that the bulk modulus of water is equal to 2.2 into 10 the power of 9 Newton per meter square. Take G is equal to 10 meter per second square. It is the acceleration due to gravity. Let H be the depth of water column and rho be its density. Then what should be the pressure exerted by this water column of the depth H? It is H rho G. So the pressure P is equal to H rho G, where H is equal to 3000 meter, rho is equal to 1000 kilogram per meter cube, which is the density of water, and G is equal to 10 meter per second square. By substituting the values of H, rho and G, we get pressure P is equal to 3 into 10 the power of 7 Newton per meter square. We have to calculate the fractional compression delta V by V. Since bulk modulus V is equal to minus P divided by delta V by V. So, delta V by V is equal to P by B is equal to stress by B. By substituting the values of stress and B, we get delta V by V is equal to 1.36 into 10 the power of minus 2. By multiplying this value by 100, it can be expressed in percentage. It will be equal to 1.36%. Today's homework questions are given in this slide. Please, you have to work out these question answers by today itself. Okay, thank you. Have a nice day.